Alright lads, how are things? So here we are again with another video, just going through basically the heating and plumbing system. Alright, so what we have here is the constructions of the theory section that you would find on our OneDrive account. So if you go into chapter 9, we've got heating and plumbing. So that is the theory section of it. And if we go back here then as well, and you go into your drawings, and there is the drawing file that we'll be using today as well. Okay, so if you can have those two opened, and this is basically going to go and talk through each of those. So we'll just look at the drawing slide show first. So basically what we have here is a line diagram. So it's a line diagram because basically it's just simply lines showing a 2D version of your heating system. All right, so there's a couple of kind of major components in it, and then a lot of basically pipe work. All right, so to start off here, we have our hot water cylinder. Okay, so there's the cylinder that you're going to have in your house to store and keep all your hot water. That water has to be heated, and generally what we'll be talking about in questions that we'll be coming across is heated via two sources. So it's a twin coil, so there's two coils there for heating it. One is going to be from, say, like a wood burning stove, an oil burner, some sort of a fossil fuel generating the heat. Second means then is generally what we're going to be talking about is a solar collector. All right, so the two of those combined is going to heat your water in for your house. All right, that hot water then gets used for all your hot taps, your bathroom, your kitchen sink, all the likes of that, for water that you would be extracting out of the system, and also to heat your radiators to provide central heating for your house. Also, we're going to generally be talking about two-story houses. So we're going to have a lower floor and an upper floor. All right. Combined with that, then you have the blue is obviously your cold water piping. Red is your hot water piping. So where does the water start? So it starts by your mains feed. So this is the direct feed into your house. All right, and off of that main feed in, you can see that there are two kind of T-junctions coming out. There's a T-junction here and coming up into our hot water or cold water storage, should I say. So the first T here goes to your downstairs kitchen sink tap. All right, so that tap is fed directly from the mains. All right, so following this pipework up here, we then have our cold water storage tank, generally located up in your attic. All right, so your mains feed comes in and feeds that tank. So the mains feed in feeds your cold water tank up in your attic and also your kitchen sink tap. All other cold water is going to come from the cold water storage tank. All right, so that's the idea. Say if the water is shut off or whatever, that you have a supply of cold water in the house, all right, to keep all the systems running. Now, you don't want to let that cold water storage tank drain, or you'll end up then getting the likes of airlock in the pipework, and it's just a bit of a, you might have to, if you can't do it yourself, you might have to get a plumber out and they would have to come and un-airlock the system basically. So what happens this cold water once it is in the tank in your attic? All right, so the feed comes out here and it comes down and it enters into your boiler, or yours, not into the boiler, but into your hot water cylinder. All right, so cold water comes and fills this cylinder. All right, any water that comes out has to be replaced by new water coming in. So the hot water, remember heat rises, so your hot water is extracted from the top of your cylinder, all right, and your cold water enters via the bottom of the cylinder. If these two coils, heating coils, are in operation, then the water is going to increase in heat, and then that will in turn supply either your radiators or your taps or whatever that you're going to need, your hot water, your showers and all that if you don't have electric showers. Okay, we have a couple of pumps on this. So you have your stove here, we've got a pump located on the cold water piping coming from the stove to pump and draw basically the water back through your rad system into the stove to be reheated and to be sent back out to your rads as well. We have also then a pump coming from your your solar collector. So again, to draw cold water in, it is heated via the solar panels and it returns as hot water and into the cylinder. All right. Couple of safety features. All right. So along with your pump, you can see these little arrows here. All right. So kind of two arrows pointing into each other. So basically they are shut off valves on either side. All right. So we can shut off the water either side. Say if we had to replace that pump, we can just simply close off that valve there, close off that valve, remove the pump, put in a new pump or whatever it is. If we want to, say, cut off the water in the house, you can cut it off on the mains feed coming in. So you can, this is basically the likes of your stopcock out on the road. So you can turn off that valve there and no cold water will enter the house. You can also generally will have one coming from your tank in the attic. So that can be shut off as well. And you can see there's a couple of shut off valves there. So they are just a couple of safety features in it as well. All right. Another safety feature, okay. As water increases in heat, the molecules will expand. All right, that expansion has to go someplace. So the increase in the volume of the water that you have in your pipes has to go someplace. All right, and generally what we're going to be talking about here is an expansion tank. All right, so the idea that hot water in the system gets heated and it can go then into an expansion tank if it's a seal system, or it can be vented out if it's a vented system. Also, similarly, we can have that if for whatever reason that we may need an expansion pipe here coming up, and it will backflow into your cold water storage tank in the attic. And again, a safety feature of that is that we have an overflow pipe that if the volume of water should get near the top, an overflow pipe will carry the excess out, and basically generally it's piped into the gutter work and it's cast away outside of the house. All right. Other safety features here are efficiency as well, I suppose you could call them, is say thermostat. So we've got a zone system here, so we don't have to have all the hot water on in the house. We can have that, maybe just the radiators in the downstairs living area are switched on during the day. All right. Then we might maybe want to, maybe 5-6 o'clock in the evening, turn on the rads in the bedroom so that the bedrooms are warm for when you're going to bed. So it's a zone system controlled by thermostats and control panels up here. All right. And basically that's it. So following through from the drawing here, you have generally, this is just basically laid out for an A3 sheet. So you're going to have to draw out a line diagram out here. Generally, you're going to be using your board and T-square for this. So these are basically rough sizes and rough locations to suit. All right. Now, most of you have done that and you've done a good job on it. Just make sure that as you're doing it, that you actually take the time to use the different color biro for the different hot and cold water feeds, and also label things up. All right. So basically that's your diagram there for the line diagram that you might be required to produce. And if we just have a look, before we look at the theory side of it, we'll just have a look at a few of the questions that have come up in the past. So if we look here at 2018. So here we have a wood burning stove combined with a solar collector is used to provide central heating and hot water for a compact 3-bedroom 2-story house. Now, we'll just read this sentence again because there's a couple of points here that generally always come up. We're generally more than likely going to always have a 2-story house. So we're going to have to show our radiators on the ground floor and on the upper floor. We're generally going to have 2 methods of heating. So we've got our solar collector here and also a wood burning stove. So generally we're talking about a twin coil hot water cylinder. Question A, B and C, different 3 parts. A is generally always the same. It is always our line diagram. So use notes and a single line diagram show the typical design layout. Okay, so there we have our line diagram that we just seen a second ago. All right, so that is the drawing that you would need for full marks for section A. Now, take account of what they're actually asking. See here, they're included for 3 radiators. We only had 2, so you would just extend on and include an extra rad. So in this here, you would just mirror that on for a 3rd time. okay, but nothing else is different. Part B, using notes and freehand sketches. Describe 2 features that ensure the system operates safely at all times and discuss the importance of each. So we'll have a look once we come to the theory at all the various different safety features, but we've sort of hinted at some of them already. So they're the likes of your shut-off valves, all right, they're your control, your thermostats, your expansion tanks, your expansion and overflow pipes, all of that sort of stuff leads into the system operating safely. And part C then, using notes on a freehand sketch, show 2 design considerations that should be taken into account when selecting a preferred location for the stove and chimney, and discuss the importance of each. So basically, where do we want to locate the stove and the chimney? Right. If we just scroll down here and we have a look at it, in that we've got a bit of a wall here behind us. So we have basically our stove here, generally in your kitchen or one of the busier rooms you might have in a sitting room or whatever. If this is working, all right, it's generating heat. That heat is going to be extracted out all the gases via the chimney. There's going to be quite an amount of heat in that chimney, quite an amount of heat in the stove. That will be radiated into the room, and that's what we want, all right? But where do we fit this for optimal performance, all right? Now, you might say, well, optimum performance, well, all I have to do is put in the timber and the timber will burn. There's nothing I can really do to increase the performance, but there is. This heat that you're generating, all right, if this wall behind that it's mounted up onto is an external wall of concrete, that concrete, remember from thermal mass, will absorb that heat and it'll store it so that when that fire goes out, maybe at night time, that stored heat then radiates back into the house. Now, if that is an external wall, well, we're not getting any real benefit from it into the house as a whole. It's only going to be pumped back into the room that the stove is in. But if this was an internal wall, and say behind that was a bedroom, okay, so we've got a single leaf concrete wall here, that is going to absorb and store the heat as thermal mass, and then it will radiate that heat out. It will also radiate heat into the room behind it. So generally, what we're talking about here is we want to locate this system here on an internal wall. The same thing with the chimney. And if you go to any of these marking papers here, you can get the solutions and they'll talk through each of these. Now, I'm not going to go into the solutions at the minute. But again, we'll go down to 2015 and have a look at it. So part A is the exact same. So using notes and a single line diagram, all right, show the design of such a system. What are we talking about? 2-story dwelling, 3-bedroom house, wood burning stove combined with a solar collector. All right, so exactly the same for part A. Part B, using notes and sketches, show preferred location for the solar water collector. All right, solar panels, you want to put those so that they're going to be exposed to as much sunlight as possible. So that will be facing south. So generally what we said was our longest axis of our house will be along the east-west axis, and you're going to face these then on the roof facing to the south, maximum sunlight. Using notes and sketches, discuss 2 considerations that should be taken into account for the design stage of the house when selecting your location for both the chimney and the hot press. All right, so if we go back to our line diagram here, so the chimney and the hot press for the stove. So again, we've talked about the stove, that we would like this to be on an internal wall so that we're going to get the benefit of thermal mass and radiating that heat into the house, rather than on an external wall and potentially losing some of that heat if the insulation wasn't up to standard. Same thing with the chimney coming out. Now, this hot water cylinder is generally kept in what we would call in Ireland a hot press. Okay, it's a hot press because you have your cylinder of hot water within the press. All right, generally it's a 3 concrete walls blocked up, and you've got your door into it, and Generally, you might have coats and other bits of stuff just fired in that you don't want to see out of sight, kind of storage. But it's a press or a very, very small room that our hot water cylinder is located in. Again, that has got heat in it. So not all heat is going to be contained within the cylinder. Now, modern cylinders, they're extremely well insulated and they lose very little heat, but they do lose an amount of heat. They're not 100% efficient. Okay, so again, we would like to locate that room on the internal wall inside in the house, and also generally you're going to have a pump within in some place here to pump heat and pump the hot water and all that around the house. So maybe keep it a small little bit away from some of the bedrooms. If we also look now, this is a point as well that that would have been done in the past. Our cold water storage, that tank would generally be up in the attic, and the location of that generally would have been placed above your hot water cylinder, basically above your hot press. So why was that done in the past? Generally, the level of insulation wouldn't be up to standard as what we have now, so you would have quite an amount of heat loss. All right, but in the winter, all right, that heat loss from the hot water cylinder would ensure that the storage of the cold water would not freeze over the winter, the cold nights. All right, that is a very important fact. We don't want our hot or cold water, should I say, freezing, because what happens, water when it freezes, it expands, and that will crack all your pipes, and it will just lead to a nightmare situation in terms of having to gut the place, redo the pipes, decorate, all the rest of it. So the heat that will be radiated would generally keep that from freezing. Sometimes, you might have a hot lamp fitted so that water will not freeze. If that isn't the case, on very cold nights, you can set them that there's a thermostat and they might kick in at -4 or 5 degrees or whatever, and then the hot lamp will prevent that from freezing, whatever the case may be. Uh, 2013, right, so again, 2013, so same thing again. It is proposed to use a wood-burning stove combined with a solar collector to provide central heating and hot water for a 2-story house. So, line diagram, so again, A. So we've seen now 3 years, the part A has been the exact same. And A is going to get you the bulk of your marks because it's going to take you the bulk of your time. B, using notes or freehand sketches, discuss 2 design considerations that will be taken into account when citing, should I say, a solar collector. So basically, what do we need to take into account of your solar panels there on the roof? Where do we need to face them for maximum efficiency? 2 considerations. C, discuss in detail 2 advantages and 2 disadvantages of the heating system outlined at 4. All right, so what do we mean? 2 advantages of having both a wood burner and also a solar collector to heat your water for the house. All right, so we'll be looking at those in a minute, but generally you can come up with those even if you never study construction studies at all. Wood burning stove, you're able to use renewable sources of fuel. So if you were to buy timber that is managed and sustained, then that is a renewable source. Yes, I suppose it's emitting greenhouse gases, but it is a renewable source. Compare that to oil. Also an advantage then would be that we're using solar water collectors so that we're able to have free heat, basically, if you want to think of it that way. You're generating heat from the sun's rays, so that is very good for the environment. Disadvantage would be that you're using a wood burning stove so that you're releasing greenhouse gases, so it's both an advantage and a disadvantage. And another disadvantage, I suppose, what could you say? I suppose the raw materials that goes into making these cells is kind of damaging, but does the benefit outweigh the initial production costs in terms of energy and materials and all that? So I suppose that could be another disadvantage. Disadvantage could be the cost. all right, for fitting such a system. Or say if you've got an existing home, you might only have an oil-fired burner outside. To fit solar panels it might be a lot of intrusive working in the house, so that could be a disadvantage of having solar collectors. There's loads of them there. We'll have a look at them a bit more in depth later on. Again, 2011, pretty much the exact same thing. 2009, same thing. So there's a general theme here. What do we need to really know about our hot water system in terms of the exam? So yes, it's great to be able to know a lot of this for our own benefit, but we're looking towards maybe, I don't know, mid-July and early August for your exams. What do you need to know? You need to know the line diagram for your project or for the hot water system, and you need to know the safety features and also design considerations for the system itself. So with all that being said, we'll have a look now at the plumbing section here. So this is the line diagram here, and I've various numbers, points there, and if you can just work backwards and forwards there, and this basically is going to show what each one it is. So rising mains feed to the cold water in the kitchen, mains continue to fill the storage water, right? So that's basically telling you all about the system itself. All right, so I'll assume that you're well able to read and go between those two PowerPoint slides there. Now, talking about the expansion tank, so we touched on it before, but say basically, if we look at this diagram here, is a nice illustrated diagram of basically as water heats, its volume increases. So as you're heating the water in your system, that water is going to take up more space in the pipework. So that space has to come from someplace, all right? If it's not, it's going to be like a little pipe bomb and it will explode. That's not what we want. So our expansion vessel here, expansion tank here, allows for the expansion of that water as it's heated to fill up and take up this space. Now the size of that expansion tank would be based on the size of the system, and your plumber would be able to specify that for you. So you wouldn't have to be worrying about, is my expansion tank too big, too small? Okay, generally it's a fairly small sort of, I don't know, maybe a 30-40 litre tank. Not too big, but it is of vital importance in your system. So other safety features here, it keeps water in the system topped up. Oh yeah, so as well as that, as you would be removing water, and that eventually the system is going to reduce in volume of water. So along with the so if we look at it here, so along with water coming out of your hot water cylinder, okay, your pipe work here for your radiators is generally a sealed system. So that system is independent of your hot water taps and all that. Yes, the water comes in here to get heated, but that water is in a pipe. It doesn't mix with the hot water that you'll be extracting out for washing and showering and all that. But as this water is heated, right, you're inevitably going to lose an amount of that water as well. So the idea that we need to keep that water topped up also comes from your expansion vessel. Just a diagram here showing how the water comes into the house. So this is basically your mains pipe outside along the road. So this could be a 6, 8, 12-inch main water coming in, and you're going to have your connection coming off here. And if we look here, this is basically your meter here to show how much water you're actually consuming in the house, and that's what Irish Water would have filled in the last while and you'd be billed for. But it is also a shut-off valve, so we can knock off the water there if you're doing any repairs or working in the house where you don't want water pressure to be in the house. And that's just basically showing your cold water goes to the kitchen sink tap, all right, in your downstairs kitchen or wherever the kitchen may be, and then it comes up into your cold water storage up in the attic. And that is just basically a line diagram, very rough. I think I've done it on Microsoft Paint, showing your cold water storage. Okay, so you've got an overflow pipe. Should the water volume go above a certain level, that would be extracted out of the house. all right, you have your mains feed coming in, and you have just basically a ball cock here that as the water volume drops, this basically a small little plastic ball of air will drop as well, and that will open the valve here and will allow this tank to fill. As the water rises, this ball will raise up and shut off the valve. All right, so the same idea is in the cistern in your toilet. And that's pretty much all you need out of that. I suppose this is here just showing basically volume of water that you would need for various buildings per household, or per person, should I say. So a hotel, you would be looking at 90 litres per person. Storage hotels, various different, you can have a go at them there. Cold water storage, right? So yeah. Having a look at our twin coil boiler, or not a boiler, but our cylinder, should I say. So twin coil, right, means it's heated by two sources. So solar collector here, so cold water comes via a pump up through your cylinder, your pipework here. It is heated up and it comes back, returns as hot water into the bottom of your tank. Hot, as the water rises, the hot water goes to the top, cooler to the bottom, and that will keep going. So on a nice sunny day, you might turn on your tap and notice, oh, the water is absolutely scalding hot. But on a cooler day, your system isn't going to be working at the same level and the water isn't as warm. To top that water up in heat, you can have a boiler. All right, so oil, wood, whatever here. So a boiler here, cold water again comes out, is heated and returns back as hot water. We can also have, some tanks are fitted with an additional electric heating element. So basically, if you're talking about showers or that, it's your immersion. So you can have an immersion heater here, so that basically heats the very top of the tank, so that you would get an extra injection of heat into the tank if you need a shower, or if, for whatever you might need. And this is just basically how it works, and again, you're well able to read that in your own time. All right, solar collectors. All right, so here, so some of the advantages and disadvantages of this system. All right, so advantages in that it saves money, as less coal oil is needed to heat the water because you're generating it via solar energy. Better for the environment. Disadvantage, it's expensive, as we said, to retrofit. Sometimes if you've got a single coil tank, you will have to replace that tank and refit a new double coil or twin coil. So there's advantages and disadvantages to both. Positioning then of your solar panels. So as we said, you want your solar panels to be faced on the south facing, so along the east-west axis is optimal for maximum solar gain. Remember, we've looked at this diagram countless times. So this is for room layout, but also for solar water placement, or for solar panels, should I say, whether they be hot water or for electricity. Ideally, panels should be roughly about 45 degrees of pitch, so that it will be catching the majority of the sun at 90 degrees, so that again, maximum absorption from the sun's rays. If we have a look at the boiler, now the boiler is an interesting component as well. There's a couple of safety features in it, and also, so basically you have your combustion chamber in here, where whatever fuel that is where it's going to be burned, you will have pipework coming in, so the cold water coming in, it gets heated and it comes out, returns as hot, and that is a continual loop system here. All right, your gas is coming off via the chimney. All right, and if we look at here again, we've got a thermostat, which, if we look at a control panel here, so that's going to control the heating of the whole boiler here. We've got a thermostat, we've got a pressure release valve here. You've also got your supply from your fuel, if it be oil or gas or whatever. And we also have a fire safety valve, that the flame, that if there was an error in here, that can't travel back and ignite the actual supply of fuel. And that is basically what we have there talking about it. I suppose just the number 6 there, your pressure release valves. So if there was, for whatever reason, a build-up of pressure here, then we have a pressure release valve here that will allow that pressure to be reduced safely. Other safety systems they are talked about. Now we've talked about these already, but you've got your overflow pipes, your expansion vessels, and the likes. And this is just, I suppose, maybe a diagram to look at the safety system more closely. So you've got your expansion vessel, all right. You have your boiler. You have safety features associated with the boiler, and also from your hot water cylinder, you've got your expansion pipes, and they're piped back into your cold water storage. If we look at our fuel system again, and I hope you like my Microsoft Paint diagrams here. I must sort of redo these at some stage. But basically you've got your supply of fuel, be it oil or gas, and that comes in. You've got a fire safety valve here, prevents any regression of a flame or anything coming back in here. And I suppose the last one then is insulation. Obviously you want your hot water tank to be completely surrounded by insulation so that any heat that we're actually generating isn't lost. So rigid insulation, and generally you might, in an older house, you might have what's known as a lagging jacket. These now, rather than putting like a jacket onto something, you would actually have this come pre-fitted on when you buy it. Same that with your copper pipes, you can have these that they're insulated, so again that you're not losing heat. And also important that if these are up in your attic, that you're not actually going to have frost freeze the water within the pipe and cause a crack or a burst, and that is not what you want. If we look here, then your thermostat and your boiler, so basically it's a heating element, and that will regulate the temperature within in the stove. So say if you want your water that is heated at 60 degrees, so that the pump comes on and pumps that water around into your rads. When it reaches 60, 65, you can set that from the boilers and the pump. So you've got your thermostat here as well. You can also increase it, say, or decrease it in warmer or cooler months. So if you have this set that the water will not pipe out or flow out until it reaches 70 degrees, well, that's taken a good amount of energy to heat up the water to 70 degrees. But 70 degrees might be too warm for the summertime. So you might only want in the evening from 8, 9 o'clock when you're sitting down for an hour or two for the heat to come on. So you might need it as warm. Okay, so you're going to be able to use less heat to generate, say if you want to reduce it down to 60 degrees, so that we can use less fuel, but you're still getting the benefit of your heat. Your zoned system then, so generally this is what we're talking about, having 2 stories here. So your line diagram, you're generally going to have a ground floor and upper floor. Advantages of having a zoned system is that you can control different areas of your house independently of each other. So the rooms that you use most often, you can have, if you look at our diagram, you can have these as a hotter room, and the rooms that you use less often, you can have at a lower temperature. Now you can have thermostats on the radiators if you have radiators, or if you have underfloor heating, you won't have that. But you can have, say if we look at these 2 rooms here, you can have those in one zone along with this. So you can set that zone that the water or the heat keeps flowing until you hit 21, 20, whatever degrees you want. You can have in a second zone here, these are cooler rooms. So these might be your utility, your whatever they are, a few bedrooms, whatever. These are at a lower temperature, and again, you're saving heat when you're talking about having a lower temperature. So you're saving heat for not having to have the full house up at 22 degrees just because you want this room nice and toasty. So that might be your living, sitting room, whatever. All right, so advantages, disadvantages are there. I'll let you go through them yourselves. Zone system here, basically how does it work? Basically you've got your boiler, you've got your timer, your automated valve here, and it allows for quite a degree of control over the heating in your house. And again, smart technologies, some of these will operate via your mobile phone, via Wi-Fi, so you can actually plug these in so that you might be away for the weekend and you're coming back then Sunday evening, and at 3 o'clock you say, right, the heat is going to come on for 2 hours, and you will arrive back at 5, and the room, or the house should I say, is nice and warm for you. So there's advances with technology and all that, and we need to keep abreast and keep moving with technology as well. So that's a good overview of the heating system. Again, what do we need to know? We need to know the line diagram itself, how to draw it. We need to know the safety features and generally the location of, say, your solar collector, and basically your if it's a stove, your wood burning stove, and the chimney. And other than that, there's not a huge amount to that. Okay, so best of luck